Okay, this is video 3 for quantitative data analysis techniques. In this first stage of analysis of quantitative data, hang on. The third stage of analysis for quantitative data is referred to as descriptive statistics. Descriptive statistics provides a clear and concise way of describing the quantitative data that's been previously organised and presented. However, within this stage, the data is described into numerical formats at a basic level. All the studies convert the data into a format that requires no interpretation, unlike stages among the qualitative data analysis. This method of describing a researcher's statistics can be split up into two groups, which each contain a variety of dynamics. Firstly, we have central tendency. Central tendency are used to describe single number values, whereas the other group, known as dispersion, is used for measuring a spread within data, which often shows variability. The third method used for describing statistics even within the central tendency section is mean. Mean is a highly popular method which is often used in basic mathematics in order to find a form of average within a data set. This is worked out by adding together all the values within the data and then dividing that result by the number of individual pieces of data that are present within the study. For example, within figure 7, I've set up a table that contains a group of British gymnasts sit and read results. If, for instance, a researcher wants to establish the mean for their results, they would take all the data and add them together, which in this case would give them a value of 484. Following on from this, the researcher would then need to divide the figure by the amount of research results collected. For example, in figure 7, 484 divided by 14 is indicated to be 34.6, which provides us with our mean value. This figure can then be used to describe the research data by acting as a summary figure for where the data lies. In terms of benefits for using this method, the mean acts as a way to include every piece of data set that has been recorded, therefore not leaving any pieces of data left out and consequently improves the validity of the study. However, this method does have its limitations. This is because it can be highly vulnerable to outliers where pieces of data that may be an anomaly or irrelevant to the study can disrupt the description. This especially occurs when a researcher uses a small sample size that they may struggle to develop a consistency in their data. Instead, the data may be spread out due to reduced attempts made to record the findings and therefore may provide a description of stats that lacks validity. Whereas the next method for describing statistics within central tendencies for quantitative research is known as the median. The median describes the figure collected that is in the middle of the data set. However, this is only relevant when the data is ordered in terms of magnitude. Because of the fact that a researcher may not know how many pieces of data they will collect prior to their study, the number of pieces varies from an even amount to an odd amount. As a result of this, when establishing the middle number within the data set, there are two different outcomes that can be obtained. For example, in figure 9 we can see that a researcher has recorded figures regarding British gymnasts' upper arm girth. Entitled the research in this case has made 14 recordings, which acts as an even number. Therefore, the median value will fall between two figures where the data is ordered in magnitude. In this case, the median value will fall between 30 and 32, where there is an even number of values recorded. Although it may seem like it would be easy for a researcher to therefore work out the median value from here out, they may have to deal with more complex figures in other studies. As a result of this, the researcher would add the two middle values together, 30 and 32, and then divide that by 2. As pointed out on the two middle values together, as pointed out on the diagram within the slide, this leads to a value of 31. Consequently, the figure of 31 would now act as the median value and therefore can be used to describe the researcher's findings at a later date in the most efficient way possible. This is because the newly established figure will save time and effort when attempting to draw conclusions from the study. However, if the amount of values recorded would result in being odd value, then the researcher would have to take the different but far simpler approach. This consists of the researcher once again ordering the values into magnitude to gain a clear view of the findings. Following on from this, the researcher would then proceed to temporarily cross out figures either side of the scale one at a time. This is because it will eventually leave them with a final value or act as the median value, as it's the middle number. Because the researcher has been left with two middle numbers, they no longer have to carry out any more calculations in their recordings, which acts as a benefit as significant amounts of time can be saved. In my example of figure 11, this eventual median from the odd number of figures is equal to 30, an additional positive that could be taken into into consideration with this method to describing data is that it isn't influenced by outliers. Outliers act as a value that can be regarded as anomalies within data and usually end up affecting the final outcome to a significant degree. However, by using the median, the set of data is able to maintain the central value, as although there are anomalies within this, it won't affect the final median, as it's only affected by the amount of figures recorded and not by the degree of them. On the other hand, using the median can cause negatives, especially when large data sets are in a researcher, if a researcher isn't equipped with some sort of mathematical technology. This is because using the method manually often takes a long time, as it includes every figure that has been recorded, consequently reducing the amount of time that can be spent on the segment of analysing data. Next we have the mode. Whereas the mode is used as a way for the researcher to establish the most frequently recorded piece of data within their study. This particular method of describing statistics can be used for a study regarding a variety of types of data, such as categorical, ordinal, and discrete. More specifically, due to the fact that the mode is a part of the central tendency aspect of describing data, it acts as the only method for this aspect that can describe a categorical data. This is because the other methods of central tendency, like mean and median, doesn't cater for the categorical data. This is because they require a group of set data that needs to be manipulated through set calculations, rather than describing frequency within data. Following on from this, the mode is calculated by firstly ordering the values from smallest to largest, so the researcher can clearly see all the pieces of data spread out and clear. For example, in Figure 13, the researcher decided to use the mode in order to describe their stats regarding British gymnasts' resting heart rate. Therefore, they would firstly order the values from smallest to largest, so that a clear image of all the values can be formed. Following on from this, the researcher must then count how many times each of the values appears in this format. For instance, in Figure 13, the result of 68 appears twice, and therefore the researcher will record the fact that this particular value has been recorded 2 times. However, in this case, the value that appears the most amount of times is 74 ppm, and consequently acts as the mode for this study. This allows the researcher to now describe the data in a way that portrays the most common value. However, a limitation to this method could be that there may be more than one mode value. As a result, the researcher wouldn't be able to establish the singular piece of data that appears the most in their findings. Onto dispersion now. However, we move over to the other side of describing statistics, which looks at the spread of data within a study. Firstly, we have the method that goes by the title of range. The range is the difference in data in a data set between the largest value and the smallest value, therefore establishing the range in a researcher's findings as it provides a statistic on how far the values can vary. For example, a researcher that has carried out the recordings of British gymnasts' chest throw results may choose to use their range and as a method for describing their data. Consequently, they would have to carry out the first task of ordering the figures in terms of smallest to largest, vice versa. This allows the researcher to develop a clear image of the figures and act as smallest and largest figures. Following on from this, the researcher would then take the smallest figure and take away from the largest figure. This would result in providing a figure that acts as the range of the research. In this case, the chest throw study, here the smallest figure is 540 and the largest is 906. Therefore, the researcher would carry out tasks taking 540 away from 906, which would leave the result of 366. This figure now signifies the total amount of difference within the researcher's findings, which can now be used to describe what they have found in a simpler and clearer way. One of the benefits of this method is that it's easy to understand for many researchers and therefore doesn't require that much effort to use. In turn, not taking up as much time and consequently emphasizing its efficiency, providing a clear and useful description at a fast rate. However, this method only uses the extremes within the recording and therefore doesn't use all of the values. This prevents the researcher from developing a description that accurately portrays the whole study, as some possible relevant pieces of data may be missed out. On the other hand, in order to reduce the impact that one of the weaknesses that the range has on this disruption, a researcher may choose to use the interquartile range. This is because the interquartile range gives a description of the middle 50% of data and what its range is. Meanwhile, the range struggles to reduce the impact that outliers have on the final description of data. Therefore, as the extremes of data is usually where the outliers are positioned, a description provided by the range may be significantly invalid to the study, as it would be heavily based on characteristics of an outlier. Therefore, a researcher would use the interquartile range in order to eradicate this. The interquartile range consists of the researcher using a number of calculations in order to work out different percentages of the data after this being ordered into terms of magnitude. These percentages or positions within a data set are split into 3 different types, such as lower quartile, median, and upper quartile. The median allows the researcher to divide the data into 2 parts by establishing a middle number once the data has been ranked ordered. Following on from this, both lower quartile and upper quartile then divide these 2 parts once more to provide 4 quarters of data. then so that the outliers are eradicated from the statistical description. The lower and upper quartiles removed from our calculations, and the two middle quartiles come together to make the middle 50% of the findings. This then allows the researcher to find the difference between the lower quartile and the upper quartile value to find the middle 50% range of data. This is good because the more common and more relevant pieces of information are usually positioned in the middle 50%, which can now be described, whilst kicking out the piece of data that aren't too relevant to the study and can possibly describe the accuracy of the research. For example, a study looking into the vertical jump results of British gymnasts may choose to use the interquartile range in order to describe their data. Therefore, firstly, they would order their data in terms of magnitude. This can be seen in Figure 13, where I've ordered the vertical jump data from the largest to smallest. Following on from this, the researcher would then have to find the median of the data set. In this case, the median of vertical jump scores came out as 40.5, and after completing the previously stated calculation to work this out, which can be seen as in Figure 15. Sorry. Next we have standard deviation, and this represents the degree of variation from the mean result of the data. So in a study, once the mean result has been worked out, you can then go on to using standard deviation to show the spread of results, and therefore to see possibly whether or not the data collected was perhaps a fluke, or possibly just doesn't accurately represent what actually took place in the study, or could have took place. After completing these calculations, in this case it's for fine sprint test results that a British gymnast researcher may choose to use, they would then use the calculation to provide a standard deviation value. The standard deviation value can then be portrayed onto a graph, and if the curve if the curve of the graph is more spread, there is a larger spread of data. However, if it's more concise and more compact, there isn't. If there isn't, then we could make the suggestion that the data is more accurate and more valid to the research, whereas a wider representation would suggest otherwise. The standard deviation is a good method to use due to the fact that the units of measurements are the same as the values. In addition, it's often very popular in quantitative research. Therefore, if the more people use it, the more accurate it can become. However, it is hard to calculate manually, as it took me quite some time to put these calculations together. But however, a researcher would usually use some kind of a system like Excel in order to calculate these descriptive results.